So they're essentially two sides of the same coin. Deep learning is basically neural networks rebranded. Neural networks have been around for more than 50 years now, and people have been, experimenting with neural networks for a very long time. But what the limitation that people had until the 1990s or so was that we did not have the kind of compute power that was needed to really realize the benefits of using these large parameter models. And also, we did not have access before the advent of the internet to the vast amounts of data that these models are capable of ingesting and absorbing while doing pattern recognition. So what all of that changed in the early 2000s when GPU compute power applied to these neural networks and the internet gave you a virtually unlimited amount of at least unlabeled data to work with. And so the real revolution came in 2012, which is referred to as the ImageNet moment, when Hinton's team, Jeffrey Hinton's team, managed to beat all of the vision teams in the world on the ImageNet object recognition task, and they beat them by a very significant margin, which was surprising, given that their team had no real vision experts in them. So the revolution that deep learning brought about was that you could now perform these very complicated vision tasks and speech recognition tasks and so on without really having a whole lot of knowledge about the domain. So it, in some sense, democratized these capabilities to the general public, to the general developers who were, willing to just because these neural networks were able to discover high-level features from each domain. So you didn't need an expert there to tell you which features to extract. So that was the revolution. But in a sense, deep learning is just neural networks that have been scaled up in terms of the number of parameters, scaled up in terms of the amount of compute that is provided to them, and the amount of data that they are provided for training.